Namo Buddhaya, salam kebajikan. Salam sejahtera untuk kita semua dan juga tentunya selamat siang kami ucapkan kepada hadirin sekalian. Selamat datang dalam Sustainable Energy Talk dengan tema Navigating the Energy Transformation. Pada kesempatan kali ini Sustainable Energy Talk didukung oleh Asia Pacific Urban Energy Association, Masyarakat Konservasi dan Efisiensi Energi Indonesia, dan juga tentunya PT Pamerindo Indonesia. Boleh beri tepuk tangan yang meriah. Indonesia Energy and Engineering Series 2023 diselenggarakan dari tanggal 13 sampai dengan tanggal 16 September 2023 bertempat di J-Expo Kemayoran. Dan yang luar biasa, di tahun ini IEE menggunakan seluruh hall beserta dengan outdoor parking area yang dipergunakan untuk exhibition dan tentunya menggunakan lebih dari 77.000 square meter untuk exhibition area. Dan yang hadirin sekalian ikuti hari ini adalah salah satu dari 18 seminar yang dilangsungkan selama IEE 2023. Dan kita akan segera memulai seminar atau Sustainable Energy Talk pada siang hari ini. First, we are welcoming for Mr. Peter Lundberg as the Executive Director of APUEA. Welcome, sir. Not now, but I will invite you later. And then, selamat siang dan juga selamat datang untuk Bapak Gigi Udi Atmo selaku Director of Energy Conservation, Directorate General of Energi Baru Terbarukan, Ministry of Energy and Mineral Resources. Selanjutnya, welcome to Mr. Chen Kang Ten as a Vice President Head of Local Business Area, Motion ABB Indonesia. And also Mr. Peter Tan as a Business Development Manager, Keppel IAAS. Dan juga tentunya selamat datang kepada Bapak Kuntoro selaku Head of Digital Enterprise Solution Yokogawa. Dan terakhir selamat siang dan juga selamat datang kepada Bapak Rana Yusuf Nasir as a Vice Chairman Board of Expert Indonesian Society for Energy Conservation and Efficiency. Dan tentunya selamat siang dan selamat datang kepada seluruh hadirin yang sudah bersedia atau mengikuti acara pada siang hari ini. Hadirin sekalian, Hybrid Seminar Energy Forum merupakan bagian dari Pamerindo Sustainable Events yang merupakan misi keberlanjutan kami untuk menanamkan keberlanjutan ke dalam semua kegiatan yang kami lakukan guna untuk mendorong seluruh stakeholder industri di dalamnya untuk melakukan hal yang sama yang mencakup semua sisi operasional, business practice, sampai memberikan pemahaman dan informasi kepada jaringan komunitas kami sehingga dapat membangun dampak yang positif. So, on the next session, we are inviting Mr. Peter Lundberg as a moderator of Sustainable Energy Talk to lead today's session. Each of speaker will have 10 minutes to present their presentation, continue with Q&A and wrap up session for 35 minutes. So, to Mr. Peter Lundberg, the stage is yours.
Hello everyone. And I am the Executive Director of the Asia Pacific Urban Energy Association, and I'm so happy to see you all here today. Today we have actually 5 speakers here to share insights in how we can support energy transitions in Indonesia. So first we're going to have 5 presentations from the speakers, and then we're going to have a Q&A and panel discussion. So I would like first to invite all the speakers up on the stage. So first I want to welcome Ms. Devi Laxmi Safilus. You're welcome. She's a deputy director. Big hands, big hands. She's a deputy director of energy conservation for energy efficient business development for the Ministry of Energy and Mineral Resources. You can sit. You can sit. Yeah. Next, I would like to invite Mr. CK Tan from ABB. Welcome. Next speaker we have another Peter Tan from Keppel Energy as a Service. And next I want to invite Pak Kunturo from Yokogawa, Indonesia. And last but not least, Pak Rana Yusuf Nasir from Maske. Welcome. Okay, great. I will start to give a short introduction to the session here, and then we will start with the first speakers. So, can you put my slides up on the screen? This is presentation number 1. Can you put it on the screen? Okay. So the session is called Accelerating the Energy Transition in Indonesia with Sustainable Urban Energy. And basically what we're trying to do is to showcase some solutions that are available already today, technical solutions to support Indonesia in the energy transition. And in looking from Southeast Asia perspective, 8 out of 9 countries have set net zero targets for 2050 or 2065 is the latest, I think. So now there are clear energy targets or emission targets in almost all countries in Southeast Asia. And all these countries are now working on roadmaps, new energy policy, how to get there. That's the big issue. How do we reach net zero targets by 2050 or 2060? And looking at the renewable energy potential in the region is vast. The country with the largest renewable energy resource is Myanmar, followed by Indonesia and Thailand. And if you look at this is the renewable energy resources in ASEAN, divided into power sector. So you have the largest sector is solar PV by far, followed by offshore wind. Just an example from a neighboring country, Thailand. You see here that solar PV is really dominating this renewable energy resources in Thailand. And as a matter of fact, you only need to penetrate 1% of the available solar PV resources to reach 49 gigawatt, which is the total installed power capacity in the country. And looking at Indonesia, solar PV is also the largest potential when it comes to renewable energy. And I think you need roughly a penetration of 3% of the solar PV resources to cover 80 gigawatt, the power supply in Indonesia. So solar PV is the largest resource, followed by offshore wind, hydro and geothermal. I just want to point out also that buildings are accounting for a large part of CO2 emissions globally. If you include both building operation and the materials and construction, is close to 40% of the global CO2 emissions. So buildings play a very vital role in the energy transition here. And not at least, we talk a lot about renewable energy, but energy efficiency is also a key. It's as important actually as renewable energy, and we will hear many speakers talk about that. And if you look at further in the buildings, this is a typical breakdown of a building in Southeast Asia, a commercial building. You see, cooling is 60% of the electricity consumption. So we have to remember to address cooling. Thank you, Keppel, by the way, for let me borrowing this picture. Just want to highlight, what we need to do to integrate more renewable energy. So we talk about batteries a lot. Everyone understands batteries. You charge them when you have excess electricity from solar and wind. You discharge them when you need to. But we all know batteries are expensive too. So if you're looking back to what I just showed you on the building side, that cooling is a major part of the electricity demand. So another form of energy storage is thermal energy storage, basically a cold water tank or a hot water tank. So you can produce chilled water, in this case, with solar and wind energy, and use it, and save it, and use it for later. And what's the benefit with this? Yeah, these kind of systems are up to 100 times cheaper than battery energy storages. So we have to remember that it's not only batteries we have to look at. We have to look at thermal energy storages too. Okay. This was just a short introduction from my side. I want to move and introduce our next speaker, Ms. Davi Laxmi Safilus, who is going to give an Indonesia energy transition outlook. Davi, the floor is yours.
Thank you, Peter. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, Bapak Ibu, hadirin peserta workshop Accelerating the Energy Transition in Indonesia with Sustainable Urban Energy. Permisi, saya mewakili Direktur Konservasi Energi. Saya membacanya dalam bahasa Inggris karena sudah disiapkan. Permisi ya, Pak. I'm deeply honored to stand before you today at this prestigious workshop. It is indeed a significant moment for Indonesia and the global community as we discuss the vital topic of energy transformation. Yes. Indonesia has been taking concrete and substantial steps toward a more sustainable, environmentally responsible future. One of the key commitments is to reduce greenhouse gas emission. We have increased the target significantly, aiming for 31.89% reduction in emission with own capabilities and an impressive 43.20% with international support, as outlined in the enhanced NDC 2030. The commitment to reducing emission is not isolated. Indonesia has joined hands with the international community in the pursuit of a net zero emission target. The Just Energy Transition Partnership, or JETP, and the Asia Zero Emission Community, or AZEC, embody this commitment. JETP, established in February 2023, is poised to support Indonesia's ambitious energy transition, particularly in electricity sector. In August 2033, we achieved a significant milestones with the release of the second draft of the Comprehensive Investment Plan and Policy document under JETP. This document lays out the strategic roadmap to guide our energy transition efforts. Currently, Indonesia is diligently updating the draft of NZE roadmap. This roadmap outlines national strategies to achieve net zero emission by 2060. The main strategies include electrification, new renewable energy development, early retirement of coal-fired power plants, carbon capture and storage or utilization implementation, and energy efficiency programs. In the industrial sector, we emphasize fuel switching, electrification, the use of hydrogen as a substitute for gas, and the application of CCS technology. Next. According to IEA report, nearly 300 billion USD was allocated for energy efficiency in 2021, illustrating high potential value for energy conservation globally. The energy demand growth rate is projected to rise by 1.8% per year. Energy demand is expected to increase from 142 million TOE in 2020 to 519 MTOE in 2060. Business as usual. Through mitigation action and energy conservation activities, it is estimated that there will be a decrease in energy demand by 209 MTOE or 40%, so that energy consumption will be 310 MTOE in 2060. In the Enhanced NDC 2030, energy efficiency and conservation activities will contribute to GHG emission reduction of 132.3 million tons of CO2 through the implementation of energy management, minimum energy performance standards, electric vehicle, energy saving solar road lamps, and international cooperation on energy efficiency in the industry. Mitigation activities in the energy sector must be fulfilled from their own efforts and not to be traded abroad. Other potential activity outside the enhanced NDC include CCS or CCUS, gas flare, and PLTU early retirement have not been taken into account currently in the methodological development stage, still in development stage. Next. Government Regulation number 33 2033 concerning energy conservation, which was promulgated on June 16 this year, is a replacement from Government Regulation 70 year 2009. The background to these regulatory changes is to expand the scope of implementation energy management, regulate the implementation of energy conservation within the central government and regulation government, and grow the energy service company or ESCO. The obligation to implement energy conservation through energy management is not only directed at business entities, but also the central government and regional government. Expanding the scope of energy management will open energy efficiency market opportunities. The role of energy conservation service businesses, or better known as energy service company or ESCO, will be important to help business entities carry out energy efficiency project technically with financing support involving the financial service industry. Next. Effort to reduce emission through energy conservation activities in the household and consumer sectors may include standardization or minimum energy performance standard and label for appliances, implementation of energy saving technology with electric vehicle and induction stove, increasing awareness of energy saving behavior. MAPS aims to protect and provide information to consumers in selecting energy efficient household appliances and preventing inefficient household appliances from entering the Indonesian market. MEMR has calculated the potential for energy savings from implementation of MAPS from 2021 to 2030 for 11 equipments as shown on the slide, the 11 equipments. The implementation of MAPS policy could save energy up to 8%. In 2021, a ministerial regulation has been stipulated regarding the application of MAPS for using equipment, and a ministerial decree has been issued which sets performance standard for certain equipment, which currently includes air conditioner, refrigerator, rice cooker, and fans. Thank you very much. For my closing, energy efficiency is the first fuel and has an essential contribution in achieving the net zero emission target. Government regulation, the new government regulation has been published with the aim to increase energy efficiency targets. We are confident to reach our ambition. Energy transition absolutely requires real action. Without a solid commitment from our partner, the level of achievement will not be as successful as we have planned. I really hope that through this forum we can discuss breakthroughs in the implementation of energy conservation and the potential for future collaboration to enhance our joint effort to achieve a realistic energy transition and sustainable future. I wish to underscore the significance of businesses prioritizing initiative to reduce carbon emission and promote environmental sustainability. Our journey toward a sustainable industry is shared responsibility, and together we can create a cleaner, greener, and more prosperous future for Indonesia and the world. Thank you very much. Terima kasih Bapak Ibu.
Thank you very much, Devi, for the very comprehensive introduction to the energy transition outlook of Indonesia. It looks promising. It's nice to see the potential in energy conservation. Only, for example, yes. So we'll move to the next speaker, who can, offer some solutions to help the energy transition. Mr. C.K. Tan.
Thank you
from
very much.
ABB. The floor is
Thank
yours.
you. Terima kasih. Selamat siang. Thanks for attending today. I'm a CK from ABB Indonesia. This is a short background of mine. I'm also sebagai energy manager in IMAS. So today we are talking about energy transmission, right? As we know, in the past 100 years, the energy's demand has been increased. The supply has been increased for what? 10 times? More than approximately 10 times. Lebih kurang 10 kali ya daripada 100 tahun yang lalu. Major powers that we use production is from fossil fuel. Yeah, that responsible 60% or more. And the energy transmission is a vital global mission yang semua countries committed to achieve net zero emission. Itu already confirmed. Every country has committed on it. Seperti Bu kata tadi, energy emissions will be one of the very important element, right, for energy efficiencies throughout the whole transition period. Other than we're talking about the green energies, clean energies productions, if we don't save, that will not bring an impact on it. So we can look into that's why we need to build an energy efficiency society that can help and encourage, we have the habits of living in the energy efficiency or conservative environments. So this is the background. Human population has increased from 7.7 billion approximately to 10 billion by 2015. Energy will continue goes up. Climate change is a critical issue. We are achieving below 1.5 degrees C of the temperature rise every year. So this is a crucial objective for all humankind at this moment, right? So what can we do? Seperti tadi Bu kata, data ini quite accurate, From all the CO2 emissions from the previous slide, you can see there's a 370 ton metrics, million tons. Oh, sorry. There's 1/3, about 37%, contribute from energy efficiencies. So energy efficiency itself, that is a very important element for us to achieve net zero emission. It's just like no matter how many green energy we produce, but we are not use it effectively, right? We will never achieve net zero emissions. This is very important element, which you might not see it from day-to-day life, but this is a statistic that we need to look into it seriously. Okay, take ABB as an example. Globally in our productions, we managed to save last year, in 2022, we managed to save 69 gigawatt hours in our production itself, which means we reduced 15% in all of our productions by upgrading the high efficiencies motors, right? Looking for installing a drive, looking in the areas that we could save the energies. So in a return, we could save, as a long run, we could save 1.9 megawatt hours, or every year in terms of money, we could save about $138,000, right? Other than that, ABB as a technology supplier, we also publish a lot of the white paper. This is one of the white paper is available in the web page. Related to, in this particular case, is related to water and wastewater industry. Take water and wastewater industry as an example. 45% of the cost of the water production come from the energy cost. So this is a significant numbers. We look into it, right? And there are 3.5 to 4% of the world energies consumed by water industry itself. So it's a big numbers for energy saving opportunities. And we also believe that there will be 15% opportunity on saving of this in this particular segment. We move on one of the case study. Today we have friends from Keppel as well. This is Keppel Marina based project in Singapore, in a desalination plant. ABB as a technology suppliers, we work together closely with our customer, looking on these particular projects from the testimony of Mr. E.K. Gore, that we could save 40% of the energies if we apply the technology correctly. So there is a room of saving. That is a solution for it. So to here, I just make the thing short. We invite everyone, together we win. We need to achieve the goals. Goal ini bukan dari administration aja, tapi juga from industrial, from supplier, from the user. That's why we have promoted together with MAS-KE, we have been signed the MOU to promote energy efficiency movement, under the witness of the minister as well. There are 5 steps to do. Together we will win it. We will do it together. First, we will make a commitment to improve the energy efficiency as a user, as a person, in your own plant, in your own activities. Share the commitment publicly. Share commitment itu ke orang public, ke semuanya. Act on the commitment yang kita udah kasih, udah committed. Share the progress, seperti case study tadi. Then finally we achieve the net zero emissions together, right? So dari mana caranya? We have this particular movement. You can go Google energy efficiency movement, sign up on it. There is a lots of white paper, case study, how we achieve it. Right? This is not only the ABB program, it is international program that we work with all the suppliers, with all the end users together to achieve the result of net zero emissions. Right. That's the end. Thank you very much of my presentation. Terima kasih.
Thank you very much, CK Tan, for that great presentation. Yeah, energy efficiency is really important, and it was interesting to see the graph of from, I think from IEA showcasing that is 37% energy efficiency needed, 34% renewable, and the rest to achieve, you know, the 1.5 degree target in climate change. Very interesting. Thank you very much. I'm going to move to the next speaker, Mr. Peter Tan from Keppel Energy as a Service, who's also going to talk about energy efficiency, but how we can maximize energy efficiency with district cooling. Peter, the floor is yours.
Hi, good afternoon, everybody. I'm Peter from Keppel EAS, business unit from Keppel Infrastructure. So basically, I just want to do some sharing on what we have in common in Southeast Asia, cooling. Because we are living in a tropical country, so I think the best is we maximize the efficiency in cooling part first before we do something else. Because space comfort is actually more important. Because limited of time, then I will just quickly go through. Yeah. So some of the some background. So basically, Keppel, we launched a new business model called Keppel Energy as a Service. So it encompasses cooling, EV charging, solar, renewables, battery storage, and also hydrogen productions that we have. Anything that deals with energy, Keppel is willing to do an investment on that, and then in returns, we sell that as a utility back to our customers. So that's Keppel EAS in a nutshell. So cooling in our climate is using considerable amount of energy in Singapore, plus also Southeast Asia as well. So easily takes up about 37% just solely on the plant itself. We have not even factored in the air side, the air handling units that draws power to cool the space. So this will give us, if we can improve on this 37%, then we can actually drive down the efficiency level. So for Keppel Energy as a Service under the cooling in Singapore and also in other parts of Southeast Asia, we are actually offering a service as a district cooling partner. So basically we develop the chill water plants, and then we sell the chill water back to all the developments within the district park or within the vicinity itself. Of course, to extend the same business models, we also have a retail cooling arm that we do investment in building system, helping customers and developers in achieving better efficiency, lower costs, at the same time so they can focus on their core business in doing their leasing and retail and office. So you may ask, what is district cooling? So I'm also very glad that one of the speakers shared with me that Indonesia is embarking in the district cooling in your new capital, which is a good sign. So nothing special about district cooling. So district cooling is actually a centralized chill water plant system embedded with a thermal storage, acts like a battery, so you can charge and discharge during peak hours. That will relieve off your electricity grid demand so that you don't need to have additional power plants and they don't need to generate excessive power that resulted in draining into your through the grid and become a heat. So basically the benefit of this is having a district cooling. All the buildings will require less electrical infrastructure because every building will not have any more plants. So the other part is about structural costs. That will reduce the amount of carbon abatement that you have right from the start before you even coming to construct the building or design the building. Then, as you know, most of the plants are noisy and produce a lot of vibration. This is something that you have to treat it before, if you have a chill water plants within your building as well. So with the space reduction in not having a cooling tower and not having a plant within your building, that you can enhance it by a solar panels that will offset the amount of demand in terms of electricity that you will utilize in the whole entire life cycle cost. Of course, in terms of bigger system, which will always give you a better system efficiency compared to smaller machines that we have in building. Lastly is about reliability. For Keppel, we have been operating district cooling plants for the past 23 years. So in terms of reliability, we are guaranteeing our customers about 99.99% in terms of service level agreement. We have not failed any of our customers before, even during blackouts, electrical blackouts from the grid. We still continue to supply chilled water to the data centers, and so that they can maintain and keep the information intact. Yeah. So just a snapshot about our presence in Singapore. So basically, we are the very first and also the largest cooling operator in Singapore, having to serve more than 80 developments. Portfolio-wise, we have a flagship, which is Changi Business Park, that is very near Changi Airport. That is our very first plant that we have with a design capacity of about 37 tons. And then we expanded our services to Woodlands, which supplies chilled water to semiconductors that produces wafer. And then we goes into Biopolis for R&D research, Mediapolis, and then followed by the latest additions is Bulim and Jurong Lake District, which we have just recently been awarded. And in overseas, we also have one plant in Bangkok, Samyang, which is under construction, will be operational, I think, by 2024. And also the Tianjin Eco City that we are already operating for the past 10 years. So these are furthermore of some of the retail cooling portfolios. These are the in-buildings that Keppel have invested in the building's cooling system, and then we sell the chilled water back to the building owner. That will give them a peace of mind in terms of their running costs with a better projection and also more transparency. Yeah. So some of the customer clienteles that we have, mostly MNCs and also government agencies within our portfolios. So what makes us so different is we are always improving and optimizing. Recently, we just converted our Changi Business Park to our ONC, Operation Nerve Center, which we heavily invested in AI, real-time system inputs, and then we collect those information and then we do a continuous optimization on our system. This will basically just drive the sustainability program that we have. By doing so, this plant is a positive energy in Singapore. The very first two in Singapore to have positive energy certified by our authorities. Okay, the other difference that we have is we have been doing a lot of research with our university as well. So basically, thermal storage is nothing new. So what we did to enhance further is that we also developed a very unique thermal storage with phase change material. Normally our chilled water thermal storage is water in basic for storage. So what we did is that we added some capsule balls, which is a phase change, and then we can increase the similar volume by 3 times of its capacity, so that we can actually serve more customers with the existing infrastructure, as well as also to provide more critical loads, example to the bank's data centers as well. So some value creations, basically in long run, when we do our presentation to our customers, we both showcase the life cycle cost savings throughout the whole entire lifespan of the equipment and the building plant, and also how much carbon reduction they can achieve by just utilizing the district cooling system itself. Some of the showcase, this will be the latest district cooling plant that we have been awarded in Singapore, Jurong Lake District. Then our One North District, basically this is a plant called multi-layer redundancy. Basically, the plant will support each other with two district cooling plants supporting each other in terms of breakdown and capacity. And then in terms of showcase of expansion and capability, district cooling plant, you can actually encompass your supply radius to supply to even further customers beyond 2.5 kilometers. So this is some unique part about district cooling plant in Singapore that we have. And lastly will be our showcase for our latest addition, the Samyan Smart City. This is still in progress construction. So that will have a total phase of just 2,005 tons for the initial, which is expandable to 18,000 tons. Yeah. So we believe that cooling is just a small first step that we embark. Of course, with the solar program, plus also the electrical vehicle charging, buildings can actually achieve to close to net zero. Of course, ended with the offset by RECs and also green powers moving forward. Yeah. In that case, I thanks everybody for your time. Okay. Thank you.
Thank you very much, Peter. It's very interesting to hear your perspective on district cooling as a leader in district cooling developments, I would say. And district cooling has great potential, in Southeast Asia. I think today there are around 50 district cooling systems. The largest largest market is in Malaysia with about 33 district cooling systems. But it's good. We're going to hear a case study from Indonesia here as the last speaker. But thank you, Peter, for sharing that. Okay, I'm going to move on to the next presenter, Pak Kuntoro from Yokogawa, Indonesia, who's going to talk about technology that can support renewable energy integration. The floor is yours.
Okay.
Yeah.
Thank you very much, Pak Peter. Good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. Yeah, I'm Kuntoro from Yokogawa, Indonesia. Just to share that Yokogawa is a technology provider to provide the control systems and automations and plant consultants, process consultants. This is our business in Indonesia. Indonesia we established in 1994, and right now means we almost close to 30 years. Yeah. Okay, this afternoon within 10 minutes, I tried to share, of course, in the high level of sharing that because of trying to meet with them in this afternoon, that at least 4 items I will share. First is why, as a technology providers, Yokogawa also concerned on this emissions, and then sustainability. Also, the next is what kind of technology they can provide to ensure that energy generation can be maximized and be controlled in the right way. And then next is what kind of technology right now available in the market that can support, can be utilized as a process industry to ensure that the process can run and work properly. This is 4 items that I want to share. Yeah, first of all, as a technology provider, why Yokogawa concerned on this sustainability? Yeah, this is in line on to the Yokogawa's global direction, which is our vision is to commit to the 3 goals according to the SDGs, and this has become company's global directions. Then every Yokogawa in every countries will face the similar things. Yeah? This is the first. And then if we talking about the industry of power generations, commonly that generation can be developed into 4 stages. One is generation itself, and then transmissions, and then distribution, and then the last stage is how we ensure that distribution can be managed in efficient as possible. Like so in the screen, what is Yokogawa activities? Yeah, we provide the technology to control the process on each of power generation sector, like power hydro, and then geothermal, and then WTE, waste to energy. All of that we provide the technologies to ensure that operation can be done in an efficient way. And then the next is especially for the recent trend of renewable energy after geothermal, then we now move to another source of the energy like wind farm, and then solar, as well as the energy storage and battery. Yeah. This is all of the generation that right now we have. I believe Indonesia, our country, also have this. Even the improvement may be needed according to the direction from the government that we have to accelerate this renewable energy usage. Yeah. So in this situation that Yokogawa can provide any of technology that has been proven, utilized in several customers in our region. Yeah. So talking about the renewable energy itself, what is the typically architecture of the renewable energy generation? Yeah? We can see here that we have right now we have a PV, we have a wind, we have a battery, and etc. And this is typically that in the future it will grow up, especially in Indonesia. If we refer to the government directions, that all of us need to be driven to ensure that our energy can be provided, and then this renewable energy can be provided as much as possible. This is become our government's direction. So typically this is what we planned. In Yokoga itself, in terms of how, if we have several energy resources, then how is the way to ensure to monitor the operations? So we developed since last 5 years. We call it the CI server. It's basically a data platform in accordance to the IoT theme in this region, because as we know that right now everybody say about industry 4.0. What is that? 4.0 is really depend on how the data that can be provided and can be analyzed. So CI server is one of tools, platform to ensure that data can be collected. And then as I mentioned, how to ensure that production process or generation process can be make sure that they operate in the right way, right conditions. So we provide the control technology. Yeah, here in the slide we have several equipment that we can implement it in sites. We have a Centum VP as a distributed control system. Stardom is a hybrid control system. FAM3 is a programmable logic control, and ERT plus. This kind of range of the technology or equipment, we can implement it in small size up to large size. So we provide it completely. And then talking about a bit detail about this CI server. So basically this is again a platform, data platform to ensure that we can start with digital transformations, because we can, by this data platform, we can manage how is the integrated in vertical or horizontal connectivity we can ensure with this platform. And then next is how is the Yokogawa platforms to make sure that any kind of energy resources that have been generated can be managed, can be controlled, can be distributed in the right way. So we have several activities, several equipment that we can implement it in all levels. Level 0, level 1, level 2, level 3, level 4. All of them we have provided. From generations up to distributions, controlling the distribution, we have all of this. This is our portfolio. And then recent situation, which again everybody talk about the 4.0, then IoT become the mandatory in some of customers, some of practitioners, industries. So we also provide this kind of strategy and how to do it. Yeah. Like in operation advisory, yeah, we have the way how to supervise the assets. And then the asset management itself, we also have the way how to manage the assets, how to optimize the assets. And then the last one is energy management system. In the current distributions, there is some challenge, and we also have some tools that can be utilized to solve the challenge. Yeah. Okay, for operation advisories, right now we familiar with drones. Yeah. One of the utilization is to inspect the solar PV situations, conditions. Then we can make it a cleaning. Then we can deploy these drones to maintain the situations. Yokogawa have a platform, we call it Yoroi, Yokogawa Robotic Interface. Yeah? This is the interface that we can deploy for this robot and drones implementations. This is just the video, how is it? And then about the assets, yeah, we have some tools to ensure that from level 1 up to level 4, even the cloud also has been provided. This is technology that recently available and applicable for implementations. And then how we can make sure that our assets can perform according to the design. So every time we have provided data, then we can show what is the performance of our assets. And then about this energy management. Yeah, energy management now has become mandatory because everybody wants to operate with efficient way, especially in distributions. Again, if the resource of the energy is now distributed in several resources, so how to distribute the utilization? It has become the challenge. So Yokogawa have tools, what we call it PICE. Actually, PICE is a name of company. Yokogawa Global just acquired this company last year, and the capability is in providing the algorithm through the tools to manage, control the distribution among the grid. Yeah. This is their specializes. This is the output of the PICE. What is the function? Yeah, they can run as a standard server, and they can control the PMU, and they can control the high speed precisely to manage fault at the frequency. And PICE can control the real reactive power, enabling and optimize economics. PICE is the new technology that has been developed, and they have several patents according to this PICE. They have 16 patented items, yeah, 15 in United States and 1 in Australia. Yeah. So this technology is proven, and in our region, in ASEAN and Oceania, we have 2 customers. First in Horizon Power, they implemented the PICE for distribution of the power grid to customers, and the second one is in Thailand. Yeah. This mostly the how to manage the several dorm distributed energy resource that has been deployed in their sites. So PICE is the take role to manage the operation of the distribution of the energy. And this all sharing from Yokogawa in Indonesia this time. Written to Pak Peter.
Thank you very much, Pak Kunturo. Yeah, Yokogawa has for sure really a portfolio of solutions to help the Indonesia in the energy transition and integrate more renewable. Thank you. So we're going to move to the final speaker, Pak Rana Yusuf Nasir, who's going to present a case study of district cooling in the new capital city of Nusantara. Welcome, Rana. The floor is yours.
Thank you, Peter. First of all, thank you very much for your nice introduction. Secondly, please allow me to greet the participant here by saying Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera buat kita semuanya. Terima kasih. I would like to deliver the presentation with the topics of district cooling development in Indonesia. District cooling development in Indonesia, especially is implementation in the new capital city of Nusantara. The reason for this, I think, just only a few Indonesians, including who is sitting here, okay, attending this seminar, maybe you will know about what happened there in East Kalimantan and new capital. What happened there, what is the progress of the construction there, and what is the technology and the engineering concept implemented there to support the KPI of the new city, the new capital city of Indonesia. Okay, the introduction. Okay, so this is the map of Indonesia. If you see Jakarta as the capital, the current capital, and the new capital is all the way there on the separate island, Kalimantan, Borneo Island, and the distance is about 1,300 kilometers from the current capital. And then if you look at this, okay, what is the area of this new capital? If we see that here, maybe some of you cannot see because it is covered by the, here, okay. The area of the new capital is 320,000 hectare. 320,000 hectare. The area of Jakarta itself, just only 66,000 hectare. It is almost the same as Singapore. Singapore also 67,000 hectare. But this is 320,000, okay? And what is the next information is about that. We carrying the sustainability value by having a tagline that we will build this new capital as a smart, green, and forest city. This is the tagline for us. So what is about sustainability? That all public building must be certified as a green building in the new capital. Number two, the building must implement the district cooling system. So I think this is a policy from Indonesian government to support the district cooling concept by having a decision to implement the district cooling in the building there. And then 68% area for greenery, it means that only 30% can be what is a cut. The trees, deforestation is about 70% and left the 30% is, and then 70% using renewable clean energy, 50% alternative water source, and then the walking distance only 10 minutes between building and the building. The new capital of the Nusantara, this is the pictures years ago. I was taken by myself, these pictures, July 2022. If you see that this land area is all forest, there's all green colors, no construction, no building at all. But this is the area which the new capital will be built. So if we see now, last month condition, it is already starting some of the construction by having a, what you call the road for transportation. Some of them, even the building is already started for the construction. And the total progress of this new capital until now is about the 30% plus, between 30 and 35%. So this is the future of the Indonesian new capital like this. Smart, green, and forest city. And this is the pictures, the design of our palace, President Palace complex. Okay? And this is a big, very big, and consists of about 8 or 9 buildings on this complex. And then we have some of the ministry office of the ministry coordination. On the bottom side, on the left side, it is the ministry coordinator for the economy, for the maritime and the investigation, for the human being, and for the law and regulation. And this is the complex for legislative where the parliament is here. consultative assembly, people consultative assembly is also here. It is in one complex. Okay, now I would like to ask your permission, Mr. Chairman, to just sharing about the basic concept of the district cooling in such a way in very common and simple language, not using a high engineering language, to make us understand about what is the meaning of the district cooling, the implementation, like this. So let's imagine that we have 5 buildings, A, B, C, D, E, okay? Usually, every building have their own chillers unit. So we require 5 chillers system. But district cooling, we combine all these buildings and install the central chiller plant in a different, like this. Okay, so this chiller plant will handle the cooling load from A, B, C, D, E. So for instance, this is just only for a sample. We have a 5 building. We have a 5 building, A, B, C, D, E. Let's say we take the building A, and we calculate the cooling load profile from hour to hour, from morning until evening, and we can see it is variation, of course. And then the peak load of the building A is a 900 ton. If this is the case, then for the building A, they need a capacity of the chillers about the 900 also, okay, to handle the peak load of this thing. So then we do the same thing for the other building, A, B, C, D, E, and then we can see that every building has their own peak load, which is on the yellow colors. And then every peak load means that we need the chiller plant like there. The peak loads that we have to install for building A is 900, for building B is 1200, and so on. So then the total peak load for all 3 buildings is 6,300. And to fulfill that we have to install about a 14 set of chillers. Means also we need a 14 set of a cooling tower, 14 set of a chill water pump, and also condenser water pump. But what happened with the district cooling, we just total all in every hourly basis. And then if we see like that, then the peak load of the district cooling will happen on the 5,250, which is the peak load of the total on the bottom line. It means almost 17% lower capacity than we need if every building have their own individual central plant. We already saving about 17%. The other is about that on the individual basis, we need about 14 set of chillers. But with the district cooling, with the 5,250 ton here, we need only 3 chillers instead of 14 chillers. We need only 3 chillers, 3 cooling towers, 3 pumps, and so on. So what does it mean? The total numbers of the equipment on individual basis, we need about a 66 number of equipment. But on the district cooling, we need only 40 numbers of the equipment. We have already reduced about, how much is that? 80% reduction in the number of the equipment. What does it mean? It is more simpler on the maintenance. It is lower on the maintenance cost and everything. So this is the beauty of the district cooling. The other is about the pricing. If you look at the capacity of the chillers we need, the higher the capacity, okay, we can see that the US dollars per ton will be reduced. The bigger the capacity of the chillers, US dollars per ton is less, is lower. So does it mean that for the district cooling, we need a lower investment for purchasing the chiller unit? That's the things. The other is about the efficiency. Efficiency also the same. The bigger the capacity of the chillers, the lower. Oh, this is the chiller price. It is, sorry. This is about the efficiency. So the higher the capacity, the better the efficiency. And the higher the capacity, the lower on US dollars per ton. So what does it mean? Then the investment will be reduced and the efficiency will be increased. So then the benefit of district cooling is a less number of equipment, lower on investment in the installation costs, less in energy, more efficient, lower in operating costs because the energy consumption is less number of moving parts, it's already said that, lower in maintenance costs, reducing space and room, only require one team of operators and technicians. Environment impact is reducing the carbon emission. Okay, in New Capital, we implemented the district cooling for every complex. We will go further on the President Palace complex. It is about this. In one complex, there is several of the buildings from the President Palace, President Office, Pavilion, Mosque, and everything. So what we do is we make it as one district cooling and the chiller plant located on the utility surface building here. Okay, so one chiller plant for the whole palace complex. And if we look at the site plan, so this is the surface building and this is the palace, so all the way is the chill water pipe distribution. So what we do is, again, we calculate the cooling load on hourly basis for every building using the software called Energy Plus. So what we are doing on the Energy Plus is we do hourly basis for every building. Hourly basis means 8,760 calculation for every building. And this is the numbers, okay? So if we see like this, then the total on the cooling load here is 7 million something on watt. So the building, for every building, the peak loads, building office, 365, the palace, 699 for every building individual. But for the instantaneous cooling load, okay, so this is the result of the calculation, means that the total building peak load is 2,374 and reducing to 2,027 as a district cooling, as a combined, as an instantaneous cooling load. It is already about 15% reduction in the cooling load. So if the chiller unit specification based on the Energy Plus simulation software, the building peak load total is every building peak load we added up, make the total building peak loads is 2,300 something, but instantaneous cooling load, which is the capacity for the district cooling, is 2,000 something. But it is not only until this, because we have also to calculate the thermal loss on the piping. There is a thermal loss, it will be the load of the chillers also. So we decided the specification for the thermal loss is not more than 0.6 degree centigrade. It means another addition of the cooling load about 187 ton. Make it as the total cooling loads become 2,214. And we decided to install the district cooling on the 2400 because we have to calculate also on the futures. So this is the specification of the chillers to fulfill the 2400 tons. We specify we need 4 units of the chillers. Each capacity is 600 ton. Okay, and this is for the design chiller in operation. 4 units of 600 ton, but we also installed 2 units baby chiller for the night load. Okay. This is the last slide. The challenge. Currently, district cooling has started being introduced to Indonesia market. This is the start that, because until now there is no district cooling. What I mean the district cooling is there is a centralized, like in Tunjungan Plaza, Surabaya, they have a 3 tower with 1 central chiller plant, but they are designed not supposed to be the district cooling. The control system, the sensor is not for the district cooling. They just thought, the designer thought, we have 3 towers, why don't we make a 1 chiller's plant, and that's it. but no control, no sensors about the total cooling load. So that's why I specified it not as a district cooling yet. The government approved to implement district cooling system in all government complex in new capital development, and it will become the showcase for Indonesia. Demand to district cooling will increase significantly after this in Indonesia, and currently the level of knowledge of professional for district cooling shall be improved by organizing the capacity building, especially in cooling load simulation, control system, and chilled water piping design and everything. So I think this is the end of my presentation. Thank you very much, Peter.
Thank you very much, Rana.
This is
Big applause for Rana. It's very interesting and encouraging to see that they have chosen district cooling for the presidential palace, and I think everyone is very interested to follow the development in Nusantara. When you're building a new city from scratch, you really have the chance to set things right and choose the best available solutions to make it sustainable. So yeah, thank you, Rana. Yeah, we're going to move to some questions, a Q&A, and I will ask the audience to prepare some questions, and I will ask you soon to ask questions to our speakers. Maybe I will just start with some question. And I mean, we have heard different perspective about from the government. We have heard from the private sector about energy efficiency, district cooling, digital solutions, drones, district cooling. So from your different perspectives, and how do you think, is there the best way to accelerate the energy transition in Indonesia? Is there some specific thing that you think Indonesia should focus on to really accelerate the energy transition? Start with you,
Yeah.
Devi.
For enhance the energy efficiency in Indonesia, first we must doing energy management for the mandatory sectors such as industry, also building and transportation, also for mining, power plant and refinery, like that. And then the second is the implementation of standard minimum energy performance standard and labeling in the appliances, even in the household, also maybe in the industry or in the building with chiller and boiler, like that. And the other is for awareness. The first thing is awareness. We must doing behavior change, yeah, to become a culture, like energy efficient culture, like that.
Great, that's great. Yeah, awareness is really important too. Yeah, and just a follow-up question, quick, on the renewable energy side. Is there some specific policy or anything that could speed up the development of renewable energy project in Indonesia, like grid access for the solar PV or something like that?
Saya mungkin untuk yang renewable dia bagaimana untuk meningkatkan renewable gitu, Pak. Kalau untuk renewable, we also have the newest government presidential regulation for the implementation of renewable power plant, include the apa sih namanya, Pak, kok? Dan geothermal, and also for penggantian itu, Pak, early retirement of coal phase out,
right.
also include in this new presidential regulation.
Right. Yeah, that is very important.
Yeah, with the energy transition towards net zero emission, as I present.
Yes, thank you very much. CK, from you and ABB's perspective, what do you have? What is your thought on how to speed up the energy transition in Indonesia?
Yeah, I think what Ibu say is so correct. There are so many steps on it. When we talk about awareness, what are the awareness that we need to build is the awareness cost of ownership rather than cost of investment. Many times we buy an equipment, we think, oh, this one lower cost. Cost of investment is lower. But the cost of ownership, the electrics running for the next 10 to 20 years is usually is like 10 times to 20 times of the cost of equipment. So cost of ownership is very important element. And together we win, the slogan. Go to the EEM, Energy Efficiency Movement website, make the commitment, make the pledge that we will do it together. I think that's very important element. Yeah. Technology is there. There's lots of supplier. There's lots of available technologies. So we have to move forward together.
Yeah, and I agree, totally agree. And that applies to both individuals, but also to companies, or as they also are looking at the short-term return, or maybe don't consider the life cycle perspective, or they want to have the quick return profit.
Many times as a business, even a business owner, a smart business owner, they forgot. They own the equipment and they last for the next 20 years. The energy itself is more than 20 times of the equipment. So
Yeah.
easily to forget.
Yeah, so it's important how to explain that, how to share that, how to create awareness about that. Okay, thank you very much, CK. Peter, you're from Singapore, so of course Singapore is come quite far, in developing certain policies and addressing energy and the climate. What is your take on? Is there something from Singapore that Indonesia could be inspired of in the transition toward net zero?
I think we are quite similar because energy is scarce, okay, because it's all natural resources. So for Singapore, I think we are more onto taxation. So that creates awareness of energy utilization in each and every one of us. Because if it doesn't start from the ground, then everybody will just keep on abusing the utilize of energy, turning on the aircon. So in Singapore, I think as part of the educational, what the government has done is that basically they educate the younger generations in terms of how they supposed to use the energy utilization rather than looking at the cost. Because cost of energy is supposed to be affordable, to be made affordable to all, to every citizen, so that everybody can live on. But to how to actually utilize the energy, to be more efficient, to be more aware of when to turn off the aircon, when to turn off the lights. Those are the very simple things that if each and every one of us can do, that can reduce the amount of energy that we actually utilize as a nation. Yeah, so I would say that awareness program is very important right from the start when they are young, because I think a lot of young people take it for granted because it's there. Yeah, so they will just continue to splurge and utilize the energy as and when they want. Yeah.
Maybe one solution is to increase the price of energy. Then people will save energy, right?
Yeah, so just to add on, Singapore, we have additional called carbon tax coming into the picture. So if let's say everybody can reduce the carbon footprint, the taxation will not be so high. So that is another form of element that has been added into the electricity tariff, imposing to each and every one of the household. So the taxation will be another form to deter, yeah.
Putting cost on carbon, basically.
Yeah, correct.
Yeah, that makes sense, definitely. Pak Kuntoro, when you go out and meet customers and you talk about your solutions, and what is the awareness on renewable energy and energy efficiency? Are they aware of the potential, or is there something you have to explain to them?
Yeah, unfortunately, about the awareness still behind. I mean, because now they're still focusing on the existing energies, how they want to make it efficient. So, but the good thing is under the spirit of Industry 4.0, everybody now trying to start for digitalizations. Then the good thing that one of they focusing on energy, at least they now aware on their energy consumption. So of course to make the energy management first will be initialized by energy visualization. That's the energy monitoring, for example. That's the good thing that now they are starting, most of our customers starting to think about the energy visualization or energy consumptions. That's the way. Yeah, of course, for our customers quite spread industry. For oil and gas, of course, they are really aware of this. So that's why they starting how to, they are starting also to build the solar panel, for example, solar PV. And even the rate is not so high, yeah, but they starting to do that. That's what we face in during our activities.
So you have seen a change in the last years, that there is more awareness in from your customers or potential customers. Is there more awareness now than 5 years ago, you think?
Yeah, of course, yeah. There is a good progress. I can say that there is a good progress in terms of the awareness, yeah. But again, this, whether they want to build or utilize renewable energies depend on the management decision. Of course, that's related to the cost, right? So that's why everything must rely on the cost. Anyway, they have aware of this, and I believe time to time it will be improved for awareness in renewable energy in Indonesia. That's my pace.
So there's a promising development.
Yes,
definitely.
yes. Sure.
Okay, good to hear. Good to
Okay.
hear. Pak Rana, district cooling. What is the potential for district cooling in Indonesia, you think? How many district cooling systems can be built in the next 10 years?
To be honest, it is difficult to answer that question.
Yes,
because
sure,
there's
sure.
many factors influence about the development of the district cooling in Indonesia. The first problem is maybe because to have the district cooling, like we see on the Dubai, on the Qatar, the government intervention have a very important role there, where they make a regulation that for a certain area, the government said you cannot build the building with the chiller plant room.
Can you move the microphone? Yeah.
You cannot build a building with a chiller plant room on the building, because the chiller you have to have connected to one single centralized there, which is a district cooling. That is what happened in Dubai and Qatar. And Indonesia, I think, if we apply this regulation, I think the government should think maybe 1,000 times, because they are afraid that maybe the protest will come to the society. Right, Ibu? Sorry, that's one thing. Number two is that for the district cooling, we need some of the capacity building to the professional, which is we have to start from now. Otherwise, we are too late to develop the district cooling. We know that the district cooling have a more advantage and benefit. But once that we want to implement the district cooling, then everything should be ready. The professional should be there. The government is also there. And everything is already there. So I cannot answer right away or very easy. Thank you.
Clearly, there are lots of potential. If you compare to, you have a similar climate as Malaysia, you have a very large population, you have a growing economy. So, yeah, there's clearly a potential. For district cooling. Okay, thank you, Rana. Thank you. It's okay. I was just commenting on.
Commenting for?
I would like to ask
Okay,
if
thank
the audience have any questions to our speakers. Anyone? Don't be shy. Oh, Angelina, please.
Hello, Peter, and all the speakers. I'm actually Angeline, coming from Kuala Lumpur, Malaysia. In terms of like energy transition over here, I'm just wondering that is Indonesia is actually thinking of like, I believe that accelerating the whole energy transition is going to be not one single country. Is Indonesia is looking like the ASEAN collaboration on this part? And if it is yes, if you can share any like specific plans that is already in the plan for these energy transitions.
David, you want to answer? Is there any collaboration with any ASEAN countries when it comes to the energy transition or accelerating the energy transition? Does Indonesia collaborate with ASEAN or any other countries in the region?
Okay. Of course, we doing many collaboration with in regional, in ASEAN, even in energy efficiency and also renewable, and also I have mentioned in my presentation that we also support by JETP. Yes.
Right.
Just Energy Transition Partnership, and even also for Asia Zero Emission Community, AZEC.
Thank you very much. Anyone else want to reply on that? Or?
I think it is in the ASEAN's energies master plan. It's already. I attended the last 2 weeks ago in Bali, in the ASEAN Energy Forums. ASEAN is building up the regional networks that we are utilize the energies hydros from the northern of the ASEAN, connected all the way to Indonesia. So everything is already in place. It's pretty much confident that ASEAN are moving together to achieve the net zero emissions. So that's what we always believe. Thank you very much.
Thank you, CK. Rana?
Yeah, I think just for the information, I'm from MASKE, also Masyarakat Konservasi Energy Efficiency, Indonesia. MASKE is working together in collaboration with the government on the program called Net Zero Carbon Growth. And this is, I think, a part of the program that you're asking for, right? So this is our activity. Yeah, thank you.
Thank you, Rana. No, it's a very good question because the climate change is a global problem, and if you're looking from a regional perspective, you share many, let's say, challenges and solutions with your neighboring countries. I think it's a great question. Yeah, thank you very much. Any other questions from the audience? Yeah, we have one here.
Cek. Ya. Terima kasih. Selamat sore. So, I'm sorry if I ask this in bahasa, but later on people can pass it to you.
Okay.
Terutama untuk Pak Rana. Ya. Izin Pak, saya mau bertanya. Perspektif Bapak dan rekan-rekan terhadap peer-to-peer energy trading, terutama di renewable energy yang sekarang juga sudah mulai banyak di luar Pak, terutama salah satunya mungkin Vietnam. Apakah itu akan applicable di Indonesia atau nanti rekan-rekan akan terjegal lagi oleh regulasi Pak? Itu yang pertama. Lalu yang kedua, maybe this one is for you Pak Sikeng. In terms of, you said that you've done about 15% reduction of the use of the energy usage in your plant. How do you justify the return of investment, because it's going to be a little bit high to buy some modules or sensors? I mean, yeah, you said that you have to factor COO over the COI, right? Yeah, how you justify this? Because yeah, the cost is going to be high and high. And the last one is for Pak Peter, maybe Pak Rana also. In terms of retail, or how do you say the retail one? Yeah, the retail one. If we are going to do retrofit, you know, change the existing infrastructure to the retail one for the buildings and stuff, what is the, how do I say this? When is the return of investment of if we're building one or if you're building one but with the EAAS? Yeah, that's all, Pak. So thank you.
Thank you. Rana, do you want to start?
Okay. For the first question, I think because it is involving the government policy, I think it is more appropriate if the question asking to the government officers. But let's say because you have already mentioned my name, I will give some comment about that. That the first is about the renewable energy. You mentioned about that. Regional, okay. I do believe that the renewable energy in Indonesia have some problem to be solved by the government, especially. Okay, the first thing is that, like you have the intervention regulation, right? The regulation that we have to revise about the saving. You know why that the PV has have a problem? Because the payback period here in Indonesia for PV is about 9 until 10 years, which is it's not worth it financially. That is because that the PLN just only recognize 65% of the saving, right? Based on the regulation. We have to change the regulation that the whole saving is to be recognized and put on the calculation for having a deduction from the PLN. So we have to urge the government to change, to revise the regulation. I'm sorry, Bu, but this is, I think this is the voice from the society. That's one thing about that. Number two, I don't recognize your question number two, but okay, let's. You asked also for CK, right? And Peter, right? Okay.
Okay, thank you, Rana. CK, the second
Thank you
question.
very much. It's a good question, ya. Sebenarnya itu pertanyaan yang sangat valid. Kemana-mana aja customer asking how to save the energies. So the easiest way is first of all we have to look into the production output per ton, kilowatts, right, or megawatts, whatever units it is. So the idea is the energy efficiency is not compromise the production, but is to make it more effective. So contohnya pompa, yeah, is a pump. How many liters of water per meter cubes that we delivered, and how many kilowatts of the energy that we use. So that's very important. So there are a lot of ways to do it. Instead of using a conventional valve, we control it by throttling it or by bypass it. But you can use variable speed drive. You can saving easily 30 to 40%, depend on operasinya. Yeah. On the other way is we talk about COO or COI, cost of ownership or cost of investment. Is let's talk about the motor, electrical motor. Electrical motor is responsible for 70% of the all energy in the industry. 70% of all energy in the industry. Basically every plant have electrical motors. So electrical motors, we bought the electrical motors, we expect 10 years. Every customer 10 years of operation. So with that 10 years, the energy that we use, 8,000 hours per year, times 10 is 80,000 hours. Times the money that we use per kilowatt, let's say it's 1,000 rupiah. Back to the hours, back to the equipment itself, it's only 5% or 3% in some case. So barang yang kita beli, equipment yang kita beli hanya 3% daripada motor listrik gitu. So the energy that we consume for the next 10 years is 97%, and the investment is only 3%. So if we are not using a high efficiency motors, then we are losing our money. Every single second, we lost our money. So that is simple philosophy, but of course there are lots of the way to calculate. Yeah. So just to make things short, yeah. I hope I answer you.
Thank you. And Peter, number 3.
Okay, so it's my turn now. So just to answer your question about the ROI for retail cooling, let me to change away the existing building, the air conditioning system. So basically there are two parameters you need to consider. First is your capex, correct? The cost, total cost to replace a live building. Because a live building is normally, when you replace a live building, it always costs more than a green building. Because you have to consider a lot of job is night job to replace your chillers, to replace your pumps, AHU or whatsoever have you. So the other factor you need to consider for ROI is your usage. So you can compare to A and B building. Both have the same capacity, so the capex is the same, but one uses 50% lesser than the other one. So the ROI definitely will be longer. So what the retail cooling we did for our customer is that instead of let them decide what is the ROI before they make the decision to change, we come out with the investment for them. Then we justify if, let's say, business as usual, this is your cost of running over the next 10 years, 15 years. Then compared to me coming out with the investment for you, I run the plant for you. Because for us, Keppel, we have an ONC. We invest a lot heavily in AI, digital twins, and also all our algorithms that can help to maintain the system efficiency constant without any degradation throughout the whole life cycle. So indirectly, we also drive down the cost that we sell chill water back to the customer. If let's say I sell the cost of producing the chill water similar like what they are running the chiller plants now, definitely the cost will goes up very high. So it will not be competitive. So it will be a win-win situation. I come up with the capex. You don't need to worry about ROI. So you not just need to focus on what is your current cost now. Maybe every year you spend about 100,000, and then you just buy chill water from me, maybe it's 90,000. So immediately you can see the difference. But the only catch is that you have to enter into a long-term contract with us. Basically, when I invest something, I will expect to run to the useful life of the machines, which is about 15 years, 10 to 15 years of our chill water system. It can last beyond 25. Some of the chill water system can be that efficient and can be that durable. But 15 years down the road, you have new technologies coming in. That's where we will do a reinvestment again with the new technology to further reduce the efficiency down. And then that will also translate to a lower cost back to the customers. So for retail cooling, we always compare in terms of operating costs rather than ROI. So that is more transparent. Rather than, because for a chiller plant, easily, I think in Southeast Asia, I think the payback period, if the chiller system is about 0.9 to 1 kilowatt per ton at 4 million RTH per year, your ROI is close to 10 years. So I hope I answer your question. So for a building owner to wait for 10 years to see their returns, only to expect a balanced 5 years of useful life of the machine, I think financially it doesn't make sense. So that's why we launch out a retail cooling program for individual buildings so that they can enjoy similar benefits as a district. Yeah.
Rana,
Yes.
you want to add something?
Yeah. Now I remember about the second question you're asking, because Peter saying about the replacement, retrofitting, something like that. If we talk about the replacement and retrofitting, then we talk about the existing building, right? And this is very important to know that from the building population 100%, 95 or 96% are the existing building. Only 3, 4, 5% is the new building. With those huge numbers, what is the existing building efficiency? It is worse. The energy efficiency, the EKA, or the energy efficiency index, and kWh per square meter floor area per year, for the existing building is worse. They are not efficient at all. You can imagine 65% of the population is not efficient. So then what I'm urging to the government is to focus on the existing building, because most of the case, we only talk about the new building. I tell you, for the existing building, even without any investment, without costs, just only to change the behavior, we can reduce the energy consumption 15 until 17%. I'm not talking bullshit, because this is the result of the study and research from CIPSE from Europe, right? It is Professional Engineer Association in Europe make a research. They find that the potential energy saving, if you change only the behavior, it is between 15 and 17%. That's one thing. So what we do need, socialization to all the occupant of the building. Number two, there is energy efficiency or energy saving with a no cost classification. It's a lot. You can do that by approaching with a delay start, early stop methodology. Number two is just operating or just turn on when required. With this no cost implementation of energy efficiency plus the change on the behavior, we can get about the 25 until 26% energy efficiency. And it is not only talking, because I do my experience. I have a company who is running, taking care, operation and maintenance about the 16 building, commercial building, high rise. I have almost 2,500 employee on the operation, and we do what we call a no and low cost energy efficiency. It is a successful until the Sinarmas group, you know Sinarmas, right? Asking my company to assist them on their yearly basis program, what they call Energy Management Sinarmas program. They have a 16 commercial building, high rise. So friend, just focus on the existing building, doing the no and low cost energy efficiency. Thank you very much.
Thank you, Rana. I think we come back to the awareness rising and creating incentives to reward, behavioral change, right? So awareness rising and creating incentives, I think probably is a key here to access this low-hanging fruit that we talk about. And yeah, we have a question here from the front.
Okay, my name is Osman. I want to direct my question to Bu Devi here, government official. We have heard, we have seen so many solutions, new technologies to increase the efficiency of energy, conserve energy, to preserve the nature. But the challenge that we hear most are actually because of the capex, opex, ROI of those new technologies, that these new solutions is going to be more difficult to implement. So there was one solution that has been implemented in a lot of European countries, which is an open energy market, open electricity market. I don't know, does it ever cross the government to try to implement it so that the customers can choose which energy source they want to use, which electricity provider they want to use, in order for these projects, these newer solutions to be economically feasible? Thank you. Sorry for the question.
That's okay. Mas, may I speak in Bahasa?
Yes, go ahead, please.
Maybe more effective. Mas, karena ini kan kondisi kan berbeda ya. Kita mau mengubah sesuatu menjadi tadinya yang istilahnya apa ya Pak Rana, monopoli gitu ya. kemudian dibuka marketnya. Itu adalah ide yang bagus. Namun semua itu bisa dilakukan adalah step by step, dan itu melibatkan semua stakeholder dan kepentingan. Kurang lebih seperti itu, Mas. Itu bisa saja ya, mungkin itu menjadi studi, menjadi kajian atau apapun ya, kita melihat keluar, tapi belum tentu yang di luar itu bisa cocok dengan di Indonesia seperti itu. Tapi itu tidak tidak menutup kemungkinan di masa yang akan datang bisa terjadi seperti itu. Ya, segala sesuatu tuh step by step dan semua menuju menjadi lebih baik. Bukan gitu ya Pak Ratna ya? Mengubah sesuatu itu bukan hal yang bisa revolusioner, tapi bisa step by step. Seperti itu. Mohon maaf ya Mas ya. Tapi itu hal yang bagus, itu pemikiran yang bagus, kita bisa melihat keluar menjadi contoh. Tapi terkadang yang ada di luar itu belum tentu cocok di Indonesia. Tapi kita tidak menutup, kita membuka wacana, membuka wawasan begitu. Kami juga berusaha untuk mencari apa sih yang terbaik untuk penerapan efisiensi energi dengan melihat dari luar seperti itu, contoh-contoh. Namun kami tetap menyesuaikan dengan kondisi Indonesia, regulasi-regulasi yang ada. Jadi kita tidak bisa menabrak semuanya seperti itu. Oke, thank you. I'm so sorry.
No worries. Thank you very much.
Yes.
Okay. Any last questions from the audience, or everyone is happy now? Well, great questions so far, I have to say. Very good, very good. So I think it's time to wrap it up. But I have one additional question to Pak Kuntoro. In terms of the solutions that you provide in the renewable energy sector, is there a specific solution that you focus on right now in Indonesia?
Yeah, in Indonesia, we introduce this kind of solutions to most of our enterprise customer, because of course we have to prioritize which customer is suitable for them. Basically, our solutions can be implemented because we have spread products, solutions that we implemented from small to large enterprise. And we also have another approach. I mean, even let's say when we're talking about the energy efficiency, yeah, we can develop the approach from simple to complex. Simple means in a process there is a control loop. Yeah, control loop. By optimizing these loops, we can improve the energy efficiency. Yeah, that's anyway. What we in the process for small enterprise, our solution that can be implemented is, yeah, of course they need the energy visualization as mentioned before. This is mostly what they are looking for right now, and we go with them. That solution that we can provide. But for enterprise like Pertamina, our approach is different. Yeah, because Pertamina has a big enterprise, then we also approach with the big solution that implemented in overall the assets. So approach will be step by step. Then
okay,
that's what it is.
Thank you very much.
Thank you,
Pak Kuntoro. Okay, I think with that I want to conclude this session. I think it's been very informative and interesting session, and I hope you all have enjoyed it. So I want to thank you, all of you speakers, for coming here and presenting and participating in this session. A big applause to the speakers. Yeah. And I think we want to take a group photo. Someone can take a group photo before we leave. That would be great. Thank you very much for coming.
Okay, thank you so much, Mr. Peter Lundberg. And next we have a memento appreciation session to the all speakers. We please Mr. Peter Lundberg as the Executive Director of APUEA to give the memento appreciation for all the speakers. The first we give to who represent Mr. Gigi Udi Atmo. Ibu, thank you so much. And we give to Mr. Chen Kang Tan as a Vice President, Head of Local Business Area Motion ABB Indonesia. And next, Mr. Peter Tan as a Business Development Manager, Kepel EAAS. And next, Bapak Kuntoro as a Head of Digital Enterprise Solution, Yokogawa, Indonesia. And the last is Mr. Rana Yusuf Nasir. Thank you so much. So now take a picture. Yeah, in front of the table. Yeah. Mr. Peter, maybe you at the center of them. The center of them. Yeah. Okay, let's take a picture. Okay, then thank you so much to all the speakers. Also Mr. Peter as a moderator for second session in hybrid stage on the plenary hall day 2. Hadirin sekalian, dengan penuh rasa terima kasih dan tentunya apresiasi yang mendalam, kita telah tiba di akhir acara Sustainable Energy Talk dalam Indonesia Energy and Engineering Series 2023 live from Hybrid Stage 1. Kami sampaikan rasa terima kasih kepada hadirin, pembicara tentunya, dan juga asosiasi dan banyak pihak yang telah turut serta dalam acara ini. Kami juga mengucapkan terima kasih tentunya kepada Asia Pacific Urban Energy Association, Masyarakat Konservasi dan Efisiensi Energi Indonesia, dan juga tentunya PT Pamerindo Indonesia yang telah mendukung acara hari ini. Bapak Ibu hadirin sekalian, sebelum saya menutup kegiatan ini, kami mengundang Bapak dan Ibu untuk dapat hadir esok hari dengan agenda yang tidak kalah menarik tentunya, yaitu Renewable Energy Talk dengan topik Energizing Indonesia, Exploring Clean Energy Technologies for a Sustainable Future, pada pukul 9.30, dan dilanjutkan di sesi yang kedua, Industrial Sustainability Update dengan topik Towards Industrial Sustainability in Energy and Engineering pada pukul 14.00 tentunya di Hybrid Stage 1 Pre-Function Hall Day 2. Terima kasih. Akhir kata saya David Rindoreno mohon undur diri dan sampai jumpa esok hari. Bye-bye.
From IEE Lounge.